Good afternoon, class. My name is Ms. Johnson, and today we are going to learn symmetry for three-dimensional objects. So the first thing that we're going to do today is go over the vocabulary words that we need to know. And all of you have a worksheet which has your 3 vocabulary words as well as the steps that we'll need today, and we will go over the steps after the vocabulary. The first vocabulary word is symmetry, which we'll write on the board. Now, the definition of symmetry, if you look at an object, for example, a butterfly, and you can imagine that if you drew a line through the butterfly at some point, that each side would be a mirror image of the other. So, if you think of a butterfly, we would draw a line vertically, like this, through the middle of the butterfly, and then each half would be a mirror image of each other. So that's symmetry. And a good way to remember the definition of symmetry is when you hear the word, think of same, because each half is like the same as the other half. It's a mirror image of that. Now the next one is plane of symmetry. So as we already learned with two-dimensional objects, if you have a line, say you have a triangle, and if we draw a line through it where both halves are the same, which is the symmetry, a mirror image of each other, then that object has symmetry. Now for 3D objects, they don't just have regular symmetry. Because they're three-dimensional, they have plane of symmetry. So it's going to be the same type of thing, except for it's going to be with a three-dimensional object. So if you can think of kind of a line or a plane through that three-dimensional object that will have them be a mirror image of each other, that's going to be your plane of symmetry. Now the third one is axis of symmetry. Now this one has to do with rotation. So if you can think of your object and imagine a line or maybe a string hanging through it where the object is rotating around it, that's going to be your axis of symmetry. Now, as I said, you have a worksheet with the words on them, so if you get confused and you need to look at that, that will help you recall these definitions. Next thing that we're going to go over is going to be our steps. And as I said, these are listed on your worksheet as well. Now, the first step is to look at the shapes. So we're going to do 3 practice shapes up here. And then in groups, you'll have shapes that you will work on. So for your first shape, you will look at your shape and try to picture that line or that plane and determine if the object has plane of symmetry. And if it does, you'll want to determine if it's vertical or if it's horizontal. And it's possible if you have certain objects, they may have more than one. For example, in a two-dimensional object, such as a square, it would have vertical symmetry as well as horizontal symmetry, and other objects like circles, they have symmetry basically in all directions, because no matter where you draw that line, you're going to have a mirror image. So think about that. Is there a plane of symmetry? Is it horizontal or vertical? And if so, is it just one or the other, or is there more than one? Once you do that, you're going to record those answers onto your papers. The next step is to look at the same object and try to find if it has the rotational symmetry that we talked about, known as axis of symmetry. So imagine that string in the object that is going to hang through the middle of it at some point. And is it going to be rotating symmetrically? Now, after you've done this, you will also then record these answers on your paper. And then it's possible that you may have plane of symmetry and rotational symmetry, or you may just have one or the other. So for our first example that we're going to do, we're going to actually look at a tennis ball. So as we learned with the two-dimensional figure of a circle, this object has indefinite symmetry. It can go through any direction. Now, since we know that plane of symmetry is the equivalent of symmetry, but for a three-dimensional object, we know that no matter where you were to split this object, you would have a mirror image. So our ball, which represents a sphere, has indefinite plane of symmetry. Now, if we were to think about the reflection symmetry, which is axis of symmetry, and we were to imagine a string, if that string went directly through the center of the ball and came out directly on this side, this object would rotate very symmetrically around that string. And this would represent the axis of symmetry for this object. Does anybody have any questions on the ball, which again represents the shape of a sphere, which is a three-dimensional circle? Okay, no questions. We're going to move on to our second object, which is a rectangular shaped box. So we know this is a rectangle on the front because it has two long sides and two short sides. So we already have learned about two-dimensional objects and their symmetry. So if we had a two-dimensional rectangle and we were to split it here down the middle, these would both be a mirror image of each other. Now if we were to split it here, it would also be a mirror image. Now we can't split it here because if we were to fold it, it would not match up correctly. So it only has horizontal and vertical symmetry. Now if we were to think of this as a three-dimensional rectangle, like we have with the box that is in front of us, it is the same shape, so it's just three-dimensional now. Now, we still are going to have the similar symmetry, where we can have it basically across and vertical. However, because it's three-dimensional, it's going to go through the interior. Okay, so we know now that our rectangular box has two planes of symmetry, one vertical and one horizontal, that are going to go through the interior of the shape. Now, as far as axis of symmetry, which is our rotational symmetry, it too is going to go vertical and horizontal. Those are the only ways that this shape will rotate symmetrically. Anything else that we were to put that through would not be symmetrical. Now, our third shape is a little bit more tricky. So we have this light bulb. So as far as the plane of symmetry, we want to look at where we can have that plane where this is going to reflect as a mirror image of each other. So anywhere that we were to do that horizontally, if we were to split this, it wouldn't be the matching image. It would not be a mirror image. So there is no horizontal plane of symmetry. Now, as far as vertical, we could have a line through the center of this, and each side would be a mirror image of the other side. So there is one plane of symmetry, and it is vertical. Now, as far as our axis of symmetry, if we imagined a string going straight through this in the middle, like this, and it was rotating, that would be our axis of symmetry. Anywhere else through this isn't going to work, so it's just going to have that one axis of symmetry. Now, does anybody have any questions on the symmetry of any of these three-dimensional objects? Okay, so now that we've done three together, I'm going to pass out some objects to your groups. Now, your guys' objects might vary a little bit, but they're all the same shape. You guys will work in your groups to determine the symmetry using those steps that we went through earlier. Remember, if you forget what any of them mean, you also have your vocabulary words. After about 10 minutes, we'll go through it together, and then I'll assign your homework. So You guys are all going to have boxes similar to this. You might have square or rectangle boxes, big or small. You guys will also have some type of sphere, in this case a ball. And then we also have this shape right here, which this is actually a vase. And we'll look at this three-dimensional shape and determine the symmetry of it. Okay, so go ahead and get started. Alright class, now that we've had about 10 minutes to work on our problems in our groups, let's go ahead and go through them together. So we will go ahead and look at this box first. This is similar to the box that we did as a class. So can anybody tell me what type of symmetry this has? Yes, John. Okay, so John and his group discussed that this box is going to have two planes of symmetry, one that's going to be horizontal, one that's going to be vertical, and it would also have similar axis of symmetry. Okay, very good. Now, what about this ball? Okay, Tom, yes, what did your group decide? Okay, so Tom's group determined that this would have an infinite number of planes of symmetry, as well as it would have rotational symmetry going through the center, which would make the ball rotate. That's going to be the axis of symmetry. Now the third object is a similar shape to our light bulb that we did earlier. There is no horizontal plane of symmetry. There is going to be one vertical plane of symmetry where we would have that mirror image. As far as the rotational symmetry, we can imagine the object rotating evenly, but not in this direction. So we're just going to have that one axis of symmetry. Now, does anybody have any questions? No questions? Alright, so for your homework, I'm going to give you a worksheet. You're going to pick two objects from your house, write down what the object is, and then write down what type of symmetry the object has. Turn that in tomorrow to the homework box in the morning, and then that's going to be the end of our lesson today. Today we learned how to tell what type of symmetry a three-dimensional object has. Thank you.